In this video, I'm going to be discussing and working through a couple problems for writing quadratic equations when you're given points. So if you recall one of our geometric postulates that we have that says through any 2 points there is exactly one line. Well, for a parabola, which is a quadratic equation, so its graph is a parabola, we're going to need 3 points. So through any 3 points is going to be one parabola. So we're going to start with our quadratic standard form equation, y equals ax squared plus bx plus c. And I'm going to plug in each one of my points individually. So I have 5, 0, 0, 10, and 2, negative 6. And each point has an x value and a y value. So I'm going to plug them in one at a time. And I'm going to set up a really nice system of 3 equations with 3 unknowns. And we're going to look for a, b, and c. And then we're going to have our quadratic equation. So our first one, x is 5 and y is 0. So 0 equals 5 squared is 25. So 25a plus 5b plus c. Our next one, x is 0 and y is 10. So 10 equals, and actually since there's zeros, 0 here and 0 here, so that just equals the value of c. So we actually have c already. And then our final one, negative 6 will be my y, and my 2 will go in for x's. So 2 squared is 4, so 4a plus 2b plus c. Well, right now I can go ahead and plug that value of 10 in for my c's. So if I come over here, I'll have 0 equals 25a plus 5b plus 10. And my other one will be negative 6 equals 4a plus 2b plus 10. So now I've already got my system of 3 equations with 3 unknowns whittled down to 2 equations with 2 unknowns. So I'm going to go ahead and put this 10 on the other side and then put this 10 on the other side. I'm going to rewrite these equations, and so I'm going to have them in standard form a little nicer. So I'll bring it right down here. So it looks like it's going to be 25a plus 5b equals a negative 10. Because when I subtract 10 from both sides. And down here when I subtract 10 from both sides, it'll be 4a plus 2b equals negative 16. Okay, well this is a super nice system of equations here. So I'm going to use elimination. So I'll go multiply by 2 up here and a negative 5 down here, and that way I'll get rid of my b's. So it'll be 50a plus 10b equals negative 20 when I run that 2 through the first equation. And then I'll run the negative 5 through the second equation and get negative 20a minus 10b equals positive 80. And my b's cancel by design. So my 50 minus 20 for my a's is 30a equals, and the negative 20 plus 80 is 60. So when I divide both sides by 30, my a value equals 2. So now I have my c value is 10 and my a value is 2. So now I just need to find the b value. So I could just plug it maybe right back into this equation. So 4 times my a value, which is 2, plus 2b equals negative 16. So 8 plus 2b equals negative 16. We'll subtract 8 from both sides. So my 2b equals negative 24. So my b should equal negative 12. Well, cool, I've got all 3 of my values. So in my quadratic standard form, ax squared plus bx plus c, I'll have a is 2, so 2x squared. My b is negative 12, so minus 12x. And my c is 10, so plus 10. So given those initial 3 points, 5, 0, 0, 10, and 2, negative 6, I know I have this parabola with the equation y equals 2x squared minus 12x plus 10. In my second example, I'm going to have 3 new points, negative 1, negative 2, negative 2, 1, and negative 4, negative 11. Okay, so I'm still going to start with my standard form y equals ax squared plus bx plus c, because that's going to be my standard form for a quadratic equation. Okay, so just like I did last time, x and a y, x and a y, x and a y, and I'm going to set up 3 nice equations. So my y value is negative 2, my first one, so negative 2 equals negative 1 squared is 1, so just a, and then negative 1 will be minus b plus c. Okay, my next one, my y will be 1, so 1 equals, I'm going to plug negative 2 in, so negative 2 squared is 4, so 4a, and then negative 2 here would be negative 2b, and then plus c, and the last one will have negative 11 equals, I'll plug my negative 4 in, so negative 4 squared is 16a minus 4b plus c. So I have a very nice system of equations, 3 unknowns and 3 equations. So we're going to go about whittling this down to 2 equations with 2 unknowns, and then we can solve that system to find one of the variables and then back substitute. So if you need help with these big systems, there's a video you can watch on that as well. So we're going to take the first 2, and it looks like maybe let's eliminate the c. That'll be easy. So I have negative 2 equals a minus b plus c, and 1 equals 4a minus 2b plus c. And I'm going to run a negative through, let's say, the top one. So when I do that, run that negative through, will be positive 2 equals negative a plus b minus c. My second equation is unchanged. It looks like my c's cancel, and that's nice, that's by design. So when I add those 2 equations, 3 equals 3a minus b. Okay, so I'm going to keep this guy over to the side for a second while I take 2 different equations and eliminate the c again. So maybe let's take the first and third equations. So negative 2 equals a minus b plus c. Negative 11 equals 16a minus 4b plus c. And again, I'm going to run a negative through to have these c's have opposite signs. So my first equation is unchanged, and my second equation now will have all different signs. So again, my c's cancel out. So 9 equals negative 15a plus 3b. And if you want to, I notice that all these coefficients and the constant over here, they're all divisible by 3. So if you wanted to, you could divide everything by 3 and just have a little smaller equation. So 3 equals negative 5a plus b, and that could be a second equation. So I'm going to put these 2 equations now, because we've eliminated c's in both equations. So I have 3 equals 3a minus b, and then 3 equals negative 5a plus b. So I'm going to set those up together. So 3a minus b equals 3, and negative 5a plus b equals 3. Well, the way that's set up, my b's cancel automatically when I add this up. So it looks like negative 2a equals 6. Some value for a should be negative 3. Okay, so let's go ahead and plug that negative 3 maybe back into this equation. So 3 equals negative 5 times negative 3 plus b. 3 equals 15 plus b. And b will be a negative 12. Okay, so now that I have the values of a and b, I could go ahead and substitute them back into, say, this first equation. So let me jot it down here. Negative 2 equals a minus b plus c. So here's where I jotted it down. My value for a was negative 3. My value for b was negative 12. And we're looking for c. So negative 2 equals negative 3 plus 12 should be 9 plus c. So it looks like c should be negative 11. Well, it looks like the battery died on my iPhone that I used to record those, so let's finish with the problem here. A was negative 3, B was negative 12, and C was negative 11. So when we put this into our standard form, y equals ax squared plus bx plus c, looks like we'll have, let's see, negative 3x squared minus 12x minus 11 for that problem. And that problem we had initial points of negative 1, negative 2, negative 2, 1, and negative 4, negative 11.